Hi, hello, namaskara. Once again, welcome back to Diksha Karnataka with yet another mock test solution video. So we are continuing with mock test 3 solution analysis. So last time we had done part 1, that is from question number 121 to 130. I hope all of you are like that video. If you have, please let me know in the comment section and also press the like button as well. And for actually, these questions are all available in our WhatsApp channel. So all you have to go is go to the link given in the description box and join the WhatsApp channel as soon as possible for all the updates. And also for those people who are looking forward to attend the exam very seriously, detaching from all the social media distractions. So there is another separate handmade link for you where you can register yourself in that particular portal. So when you register yourself in that portal, you get the PDF format of the question paper directly to your personal email IDs. So you can download, you can attend them and later come and watch the video, okay, for the solution analysis part. So please do that as soon as possible, and for more videos and content from our side, so please subscribe to our channel, and for timely notification, don't forget to press the bell icon. All right, so let us go ahead with the today's portion, that is the part 2, that is in the next 30 questions, question number 151 to 180. All right, let's see that very quickly. So the first question is, a square coil of side 25 centimeter, okay, having 1000 turns, is rotated with a uniform speed in a magnetic field about an axis perpendicular to the direction of the field. All right. At an instant t, the induced EMF in the coil E is equal to 200 sine 100 pi t. The magnetic field here is, so how do you find magnetic field? Okay, first of all, how do you find induced EMF for a rotating coil? We have a coil which is rotating. The rotating coil induced EMF maximum value. Okay, we want to find the maximum value, and because our ultimate target is to find the magnetic field, so let's take the maximum value. Maximum value is given as NBA omega. All right, so this is how you find the induced EMF maximum value. Now from this we have to get the magnetic field. So how do you get that? B is equal to E naught divided by NA omega. You substitute all the given values. So all these values are given. E naught is given, the maximum EMF induced, that is given as 200, okay, whole divided by number of turns is 1000 into area. Area is side length of the square is given, that is 0.25 meter. So you have to square it. So you will have 0.25 square into omega. Omega is 100 pi. This is omega, that is 100 pi. So multiplying all this and calculating, ultimately you will end up with the answer 0.01 Tesla. Okay, 0.01 Tesla. So the correct answer is option C. All right. So this is actually a very easy question, students. Why? Because see the straightforwardness of it. So they are asking you, they are giving you that conditions. There's a coil, it is rotating, area is given, and also what is the induced EMF is also given. So induced EMF maximum formula is this. If you know this, so you are pretty much done with the question. You can easily substitute all the values and find the answer ultimately. All right, so that's why I would put this at an easy level. So it's an easy question, no need to worry. Let's look at the next question. The magnetic potential energy stored in a certain inductor is 25 millijoules. When the current in the inductor is 60 milliampere, this inductor is of inductance. Once again, very simple question. Look at the formula. Okay, formula itself will give you an idea how straightforward this question is, right? So potential energy stored in an inductor is given as half Li square. So substitute all the given values. So we have potential energy is 25 millijoules, okay, and half into L into I square, 60 into 10 to the power minus 3 milliampere square. Okay, so just calculate all of this. Okay, just cross multiply and you will get ultimately L. You have to find L. L will be equal to approximately 13.89 Henry. Okay, so the option is, the correct answer is option C. So you can cross check all these calculations. Even in the previous question you can check the calculation yourself. If at all you are meeting with any contradiction, please let me know. All right, fine. So once again, this is a very simple question. Only thing, you have to be a little careful with the calculation, otherwise very straightforward question. All right, so yes, next question is, a resistance of 200 ohm is connected to a source of an alternating potential V 200 cos 100 pi t, the time taken by the current to change from its peak value to the RMS value is. Once again, so they are asking you to find the t instantaneous. And what instant is it? The instant is about time taken from peak to RMS. So first of all, you need to know what is the RMS value. Okay, so RMS is very easy to calculate. VRMS is equal to V peak, or the maximum value, divided by root 2. So this is how much? This is 200. Okay, 200 divided by root 2. All right. Yes. So this is the correct answer for the RMS value of the voltage. So now you have got RMS value. Now you have to take the time when your voltage instantaneous value matches the RMS value. Time taken to go to RMS value, right? So your instantaneous value is equal to RMS value. So you can take V is equal to VRMS, that is 200 by root 2. But this is already equal to 200. The instantaneous value is actually cos omega t. Okay, sorry, omega is 100 pi, it's given already. Sorry for that. Okay, it's already given, that is 100 pi into t. Now just cancel out the similar terms. Cos of a particular value is 1 by root 2. Okay, so cos of some angle is 1 by root 2. So obviously that angle is pi by 4, right? Cos of an angle, if it gives 1 by root 2, that means that angle is, argument is pi by 2. So the argument 100 pi t can be equated to pi by 4. So pi cancel, 100 goes down, t is equal to 1 by 400, which is exactly 2.5 into 10 to the power minus 3. Alright, so the correct answer is option A. Okay, 2.5 into 10 to the power minus 3. Once again, very simple question. So you have to find at what time you get a certain value. So take the instantaneous formula, equate it to that particular value. So here the value is RMS value. So what happens is that take the, you have to equate the instantaneous value to the RMS value. So you can cancel out a lot of similar terms and ultimately you get the answer. Alright, once again, a very simple problem. Alright. Now look at the next question. In a circuit, LC and R are connected in series with an alternating voltage source of frequency F. The current leads the voltage by 45 degrees. So current is leading voltage by 45 degrees. But that itself will give you a clue how to take the phase angle formula. Okay, what is the value of C? Yes, now this is slightly tricky and little bit lengthy. Okay, because we have to trade through several steps carefully. First of all, they have given that the phase angle is 45 and current is leading the inductance. So you can write easily that tan of phi, okay, is equal to, since current is leading the voltage, your inductive, so capacitive reactance is numerically greater than the inductive reactance. Okay, divided by R. Now substitute the value. So phi is 45. Okay, phi is 45 degrees, pi by 4. So tan pi by 4 is equal to 1, which is equal to XC can be written as 1 by omega C minus XL is omega L divided by R. Now you just have to solve for C, that's all. Just solve for C. So cross multiply R over here, take it over here. So you will get 1 by omega C is equal to R plus omega L. Just reshuffle everything, cross multiply, isolate C. Okay, only isolate C, nothing else. So when you isolate C, you will get C is equal to 1 by omega into R plus omega L. Now what is omega? Omega is equal to 2 pi f. Omega is nothing but 2 pi f. Since omega is equal to 2 pi f, the correct answer is actually 1 by 2 pi f into R plus 2 pi f, that is option D. Okay, so the correct answer over here is option D. Alright, so very simple, but you have to calculate carefully. Okay, so after this point, so you have to take this formula, you have to apply the given condition. After this, it's pretty much mathematical simplification. There isn't much physics in here. So mathematically you have to simplify, you have to ultimately isolate C and find the value. which is 1 by 2 pi f into 2 pi f L, okay, omega, wherever omega is there, 2 pi f plus r. All right. So this also is a simple question, but you have to be very careful. So I'll keep it somewhere in the medium level difficulty of this question. Let's see next question. A transformer is used to light a 100 watt and 110 volt lamp from a 220 volt main. If the main current is 0.5, the efficiency of the transformer is approximately. Now, how do you find efficiency? Efficiency of a transformer is given as output power divided by input power into 100, right? So what is the output power? The output power is the power taken by the bulb. Okay, so how much the bulb gets from the transformer? That is 100 watt. It's already given, right? So bulb is rated at 100. So that's the output power. Now what is input? What is going into the transformer from the mains? So we have the mains voltage, mains current. So we can find the input power as like this into 100. All right. So when this goes up, you know that this is 0.5, 1 by 2 goes up, 200 by 220 into 100. Just by looking at this number 200 by 220 percentage wise, if you see, it is approximately 91 percentage. So you can close down your value to option B, 90 percentage. Is approximately 90 percentage. Approximately 90 percentage. Okay, so the correct answer among these options are option B. Okay, once again, very simple problem. You just need to know the efficiency formula. Okay, then we can narrow it down very easily. Look at the next question. The electric and the magnetic field associated with an EM wave propagating along the Z axis. Okay, that's very, very important. Z axis can be represented by. Okay, so let me explain about EM waves. So if EM wave is progressing in a particular direction, then it is inclusive of an oscillating electric field and oscillating magnetic field. So they are oscillating in a particular direction. Okay, this direction, first of all, mutually perpendicular to each other. The oscillation of electric field and oscillation of magnetic field are mutually perpendicular. Now these both are perpendicular to the direction of propagation. So if you are propagating in Z direction, so both the oscillation of electric field and magnetic field should be perpendicular to Z direction, first of all. Okay, so wherever you see K, it's not possible. So it cannot oscillate in the direction of K. All right, only possibility is either axis in electric field x-axis, magnetic field is y-axis. Another possibility is magnetic field in x-axis, electric field in y-axis. Okay, so generally if you are getting z-axis and it is E cross B, okay, so you are getting the velocity or the propagation direction as E cross B. Okay, electric field cross magnetic field, not B cross E. Okay, so cross product is not commutative, so you can't do either way. It is E cross B. So when you do E cross B, so you will get electric field and magnetic field giving in the positive Z direction. Electric field should be in the x-axis, I cap. Magnetic field should be in the y-axis, j cap. So E cross B, I cross J will get you effectively Z axis. So once again, this is not possible because you do J cross I, you will get negative K, so negative Z axis, but light is propagating or the EM wave is propagating positive Z axis. So the correct answer is option A. Okay, electric field should be in the x axis, magnetic field should be in the y axis. So exactly when you do E cross B, I cross J, so you will get the answer as Z. Okay, so option A is the correct answer. So this is actually very simple question, but you need to know all these intricacies. Okay, all these minute detail nuances like which comes first, what is the cross product. Otherwise this will be very difficult. All right, fine. So once again, easy question, but you need to be aware of a lot of things. That's why somewhere you can put it in the mediocre for general. Okay, generally you can put it somewhere in the mediocre level. Look at the next one. A concave mirror of focal length f1 is placed at a distance d from a convex lens of focal length f2. A beam of light coming from infinity and falling on this convex lens, concave mirror combination, returns to infinity. This distance d must be equal to. Now see what is happening. So Ray diagram is mostly to be perceived. Okay, you have to get some idea of the what is happening ray diagram wise. So you have a convex lens, parallel rays are coming from the infinity. Okay, parallel rays are coming from the infinity. So when parallel rays parallel to the principal axis, or parallel rays in general, when they are incident on the convex lens, they converge because it's a converging lens. They converge at a point called focus. So all of you know this, right? So this is the focal length of the convex lens is given as f2. This is f2. All right. Now this goes, and this is meeting a concave mirror. These rays are meeting a concave mirror. All right. Now the condition is that these rays after reflection as well, even after reflection, it should trace the same path. Why? Because ultimately it has to come out parallelly, right? If it has to come out parallelly, it has to go back straight in the whatever path it has come back. So the reflective path should be somewhat like this. The reflected light should go like this. Correct? This is the reflected ray. Yellow is the incident, and this is the reflected. The reflected light should go like this. So you imagine for a concave mirror, what is that particular point from where a light ray comes, falls on the surface, and traces the same path exactly, passing the same point once again. Which is that point? It is center of curvature. So the light ray is passing through the center of curvature to the mirror. After reflection, traces the same path backwards, passing through the center of curvature. So this is actually center of curvature. If this is the center of curvature, then obviously all of you can guess what is this distance center of curvature to the mirror. It is radius of curvature, and that is given to f1. Okay, f1 is the focal length of the concave mirror. So the radius of curvature is 2f1. All right. So total distance, okay, if you don't consider the sign convention, you don't have to, because you have to find the distance, right? You just have to find the distance. You don't want which side is it, left or right, or you pretty much sign convention is out of the question, because you just want how far it is. How far is the, okay. So that is simply given by 2f1 plus f2. The only relatable answer is D, but this minus could be confusing because you might consider the sign convention, because this is on the left side, is on the right side. No need to consider the sign convention. I'll tell you why. Because we are basically finding the distance of separation. Okay, so wherever the light ray is coming from, whether it's an virtual object or a real object, whatever, we are just finding the distance between two physical objects, that is a lens and a mirror. So that you can easily get from this focal length, and adding this radius of curvature, you will get the answer of option D. There is no negative, it's only positive. Okay, if there was, it would be a printing mistake, so kindly excuse that. According to the given question and the given condition, the correct answer is 2f1 plus f2. Okay, radius of curvature of the mirror plus focal length of the lens. All right, so this is the correct answer. I hope all of you would have understood this. Once again, not a very easy question. See, let me remind all of you, in ray optics, you have to be very much careful to translate the given question into a proper ray diagram, so that you understand what is the scenario, what to apply where. Okay, so these are very, very important. Please keep it in mind, students. All right, let's see the next question. Next question is, a ray of light is incident at an angle of incidence I on one face of the prism of angle A and emerges normally from the opposite face. If the refractive index of the prism is mu and the angle of incidence is I is nearly equal to. Okay, so now there are several things here. First of all, they are telling that the angle of emergence, okay, the emergent ray after refraction emerges normally from the opposite face. That means, suppose you have a prism like this, and namely a light ray is incident, then it comes out, then it exits normally, in the sense it is perpendicular to the surface. Okay, that means it is passing through the normal of the surface. That essentially means that the emergent angle is equal to 0. Okay, simple. There is no emergent angle. Emergent ray is passing through the normal. If there is angle, it should be between normal and the ray. No, ray is passing through the normal. There is no emergent ray. At this condition, we can have, like, we have several, we have equated a lot of things, and like the refractive index formula for prism, we can use that, and because of this, you can get at a condition where you can write sin I is equal to mu times sin A. Okay, sin I is equal to mu times sin A. Since the emergent angle is 0, so you can have the delta deviation angle plus A equals I. Okay, so then you can all that the same formula. So you can work it out yourself. You can use the formula n is equal to sin A plus delta m by 2 plus sin A by 2. So there you will get the answer finally. And for small angles, if you are considering for smaller angles, for small angles, you can neglect the sine function, because sine of small angles, given the angles are in radians, it's almost equal to the angle itself. So for small angles, you can consider I is equal to mu into A. So the answer over here, the angle of incidence is nearly equal to, approximately equal to mu into A, refractive index into the angle of prism. Okay, so this is how you formulate this answer, starting from the given condition that incidence is 0. Okay, then you have to apply the standard refractive index formula of prism. How do you find the prism material's refractive index, that minimum deviation formula and all that, and then ultimately you have to get at this particular point, right? You have to get at this particular point. So yes, this is how you will get it. I is equal to, for small angles you can like kind of approximate it. That's what they are asking, nearly equal to mu into A. All right. Yes. So once again, not a very simple question, I would say, is because you have to think of all this, some wherever there is little bit higher level, very abstract mathematics involved. So that could be slightly tricky, but I hope with practice you can gain the confidence. Okay. Next question. When a biconvex lens of glass having the refractive index 1.47 is dipped in a liquid, it acts as a plain sheet of glass. Okay. When a biconvex lens of glass having refractive index 1.47 is dipped in a liquid, it acts as a plain sheet of glass. This implies that the liquid must be having a refractive index of. See, these kind of questions have come a lot of times. When you have a glass lens of certain material, okay, or any other material for that matter, if you dip it in a liquid and suppose that particular lens disappears inside the liquid, okay, it acts as a plain sheet. Okay, you can't distinguish between the liquid and that particular material. That implies only one thing, that they both are equally optically dense or equally optically rare. That means simply they have same refractive index. So please make a note of this point. It's a very important tip that you can keep in such kind of questions. If any two objects are merged or kind of mixed together, like a glass and some liquid, and you can't distinguish between both of them, okay, they both of them behave like the same or like exactly ditto, that means they both are having the same optical property, they both are having same optical density, they both are having ultimately the same refractive index. Okay, very, very simple question. Please make a note of this kind of question. This can repeat further. Okay, in different ways they can ask, but ultimately they all mean the same. All right, very simple question this is. Next question. A fish looking up through the water sees the outside world contained in a circular horizon. If the refractive index of the water is 4/3 and the fish is 12 centimeter below the surface, the radius of this circle in centimeter is. This is a very simple question. Very simple in the sense, if you would have practiced this kind of question. Now most of you wouldn't have practiced this kind of question. So for most of you, this is not a simple question. Actually, it's very simple if you understand. Let me tell you, there is a trick also here in such kind of questions. First of all, mark this kind of a question because most of you wouldn't have seen this. Now let me explain the question. What happens here is that you have a certain confinement in which there is a liquid, okay, in which you have a liquid, and now there is some kind of fish or anything inside. It's looking out, so denser to rarer medium, water to air. So because of the total internal reflection, reflection, it will be able to see only a particular area. Okay, to be precise, a given confined circular area. Beyond this, it cannot see anything, only a particular circular area. So only given things over here is the height or the depth at which that particular entity is there, and the refractive index. So refractive index here is 4/3, which you very well know. Okay, and you have to find this radius. Okay, radius of the circle in centimeter. So if the fish is able to only see a radius circle, so what is the radius? Now we all know that if at all we are applying the critical total internal reflection concept, there will be a critical angle over here, this and this, so they both are same, they are the critical angle essentially. Okay, 1 second, let me get this right. Yes, so this is the critical angle, sine theta, this is as well the critical angle. So you all know that the sine theta c is equal to 1/n, and from the image, from this particular triangle, you can also formulate the sine theta c from the triangle. Okay, from the triangle sine theta opposite by hypotenuse. So all of you know that the opposite is r divided by hypotenuse. This is h, this is r. The hypotenuse is h square plus r square, which is equal to 1/n, 1/4/3. Okay, so all you have to do here is solve for r. Okay, all you have to do is solve for r. H is given, h is equal to 12 centimeter. Okay, 12 centimeter. Just just square on both the sides. So when you square on both the sides, you will get r square divided by r square plus h square is equal to 3 will go up, 4 will come, 9/16. Okay, 9/16. Now just cross multiply, substitute the h value, isolate the r value, and ultimately you will get r is equal to, you can do the calculation and you will get r is equal to 36/√7. Yes. So option A is the correct answer. So you can perform this, you can calculate yourself. H is 12, so 12 square is 12 centimeter. Okay, so it is, h can be substituted as 12 square, 144. Just cross multiply and solve for r. Solve for r, you will definitely get the answer as 36/√7. All right, it's a very simple question, if provided you know this technique. So this trick is very, very important in such kind of question. How do you find, how do you relate this radius and all? Like this. Okay, so it's very important, students, please make a note of this. All right, so you can further expand and you can write it into a different format. R is equal to root h by root n square minus 1. All that you can do that, but time being, just solve by this method. There are several variations of this particular formula. It will just go into deeper discussion. So time being, this is enough. Okay, so please take a note of this and you can solve it further and you can do it. All right. Yes. So easy question if you know this, otherwise it's difficult. So please make a note of this question. Next question. Okay, 161. Two identical light waves propagating in the same direction have phase difference delta or dou. After they superimpose, the intensity of the resulting waves will be proportional to. Now all of you have, I don't know if you remember the superposition principle of, for two identical waves, that means they have the similar intensity, similar amplitude. Their resultant intensity is given as 4I0. First of all, 4I0 into, there is a factor, that is cos square delta by 2. Yes. So at any point, the resultant intensity due to the interference of two identical waves, light waves, is given by this formula. Okay, using the principle of superposition. So now from the equation itself, you can come to know that the intensity is proportional to cos square delta by 2, option C. So if you know this relation, it's a straightforward game. You can directly get the answer. There is nothing much to kind of discuss over here. Very straightforward. If you know the relation, you can easily get the answer. All right, very simple. Let's look at the next question. The locus of all particles in a medium vibrating in the same phase is called. So Huygens principle definitely explains, describes this portion. The locus, when you connect all the particles which are vibrating in the same phase, that is called wavefront. That particular locus is defined as wavefront. Okay, very simple. Next question. All electrons ejected from a surface by incident light of wavelength 200 nanometer can be stopped before traveling 1 meter in the direction of the uniform electric field 4 Newton per coulomb. The work function of the surface is. So once again, there are several things given over here. So there is wavelength of the light, and they are given field and distance. Okay. So first you have to find the kinetic energy. Okay, first you have to find the kinetic energy, and from there you will get the work function. So you have to take multiple things over here. So kinetic energy is given as E into V. K max is given as E into V. So here V is not given, E is given, and distance is given. So E is 1.6 into 10 to the, let E be as it is, because we will have ultimately the answer in electron volt. But the electric field and distance, that is 4 into 1 electron volt, which is 4 electron volt. Okay. So we have got the kinetic energy as 4 electron volt. Now what is the incident energy? So we have the wavelength, that is 200 nanometer. So from wavelength, how do you find the incident energy? So the incident energy falling on that is given as 1240 divided by wavelength in nanometer 200 electron volt. So you can use this relation directly, energy directly you can get like this. Okay, 124 for electrons. I'm talking about electrons, not for anything. So we are talking about electrons. For electrons, the energy of the electrons can be calculated by 1240 number divided by wavelength in nanometer. So absolutely we have the wavelength in nanometer, 200 nanometer. So when you calculate this, you will get approximately, not approximately, exactly 6.2 electron. This is the energy of the incident frequency. Now you have to apply the Einstein's equation. Simple, done. So what does Einstein's equation say? We have energy, we have kinetic. Einstein's equation says that the energy of the incident photon is equal to work function plus kinetic K max. Now bring the K max here. Work function is equal to E minus K max. 6 minus 6.2. I'm sorry, 6.2 minus 4, that is 2.2 electron volt. So the correct answer here is option D, 2.2 electron volt. All right. So this question is not easy, definitely not an easy question, because multiple concepts, you have to merge all of them and then get the answer. First, find the kinetic energy. So using the EV formula, that is charge into voltage, that will give the kinetic energy. All right, 4 electron volt is the maximum kinetic energy. Next, find the incident energy. You need to know how to find incident energy. If you don't know the straightforward formula, you will have to apply that h nu by c, hc by lambda, h nu is equal to hc by lambda, h value, c value, lambda value. And if you remember this number, easy, you can directly find the answer, very straightforward. Okay. And since you have got energy and kinetic energy, you can directly find the work function. All right. So this is not exactly an easy question, because you need to know multiple things like all this. Okay, and then you can easily find that. All right. Yes. So please, this dual nature chapter, Einstein's equation of photoelectric effect is extremely important. They can ask you in any way. So there are multiple versions of this particular one single formula. Okay, this is one of them. There are multiple versions, so please be wary of all the versions. All right. Yes. Now, next question. A steel ball of mass m is moving with the kinetic energy k. The de Broglie wavelength associated with the ball is, very simple here, de Broglie wavelength. So how do you define de Broglie wavelength? It is ratio of h by p, right? This is de Broglie wavelength, all of you are aware. And you have to now relate de Broglie wavelength to kinetic energy. So all of you know that the momentum and kinetic energy is related as a 2mk, where k is the kinetic energy. Just substitute over here. lambda is equal to h divided by root 2 mk. So the correct answer is option C. Very simple, very, very simple. You just need to know a couple of relations, you will directly get it. First of all, de Broglie wavelength, then the momentum kinetic energy relation, you will get the answer. Alright, this is one of the iterations, this is one of the versions of de Broglie wavelength. So you can directly substitute it. If you know the answer, you can directly write, you need to do all the derivations, you can directly go ahead with it. Alright, very simple. Next question. In Rutherford's alpha scattering experiment, what will be the correct angle for alpha scattering for an impact parameter B is equal to 0? Now the impact parameter B is equal to 0 means that the alpha particle is in head-on collision with the nucleus. So exactly bang in, okay, so there is no angle at which it is incident, it is head-on collision, exactly, not at the tip or the bottom tip, top tip, no, exactly head-on. So what will happen is that it will directly trace the same path backwards, exactly the same path. So that makes the scattering angle pretty much like, that is the incident angle, this is the reflected angle, deflected angle. The scattering angle between them is exactly one complete angle, that is 180 degrees, straight angle 180 degree. Okay, so this once again very simple, you just have to understand what do you mean by when what do you mean by zero impact parameter. Zero impact parameter means there is no perpendicular distance between the distance of separation between the alpha particle and the nucleus, they are colliding head on collision, so it will come back the same way, scattering angle, making the scattering angle 180 degrees. Okay, good question, very easy question. Next, look at this. Once again, this we have seen this particular question. According to Bohr theory of hydrogen atom, the speed of electron, energy and the radius varies with the principal quantum number. We have exactly seen this, where we have variation of velocity with respect to each quantum number, energy level is inversely proportional to the quantum number, and the energy we all know it is inversely proportional to square of the quantum number, and the radius being directly proportional to the square of the quantum number. So all of these relations are extremely important in this chapter. So I urge all of you to please get to know all this, and you must have it in your fingertips, okay? Otherwise even such direct questions will be difficult to answer. So from this you can see that the D option is perfectly matching with the answer. The correct answer is option D, velocity, energy and radius relation. Very simple question once again. Look at the next question. Energy of an electron in an excited hydrogen atom is minus 3.4 electron volt, negative 3.4 electron volt. Its angular momentum will be, first of all, minus 3 electron volt indicates that it is in the first excited level, or n is equal to 2. Second principal quantum, second energy level. First excited level is the second level, energy level. So n is equal to, now using the Bohr's postulate, you have angular momentum given as nh by 2 pi. So you have n is equal to 2, h is equal to 6.6, 10 to the power minus 34 divided by 2 into 3.14. So 2 cancel, approximately 2.1. So the final answer is 2.1 into 10 to the power minus 34. Okay, so this is not a very difficult calculation, you can approximate it, just looking at it you can say approximately 2.1 times. So the correct answer is option B. Okay, Joule's second. Very, very simple question. Provided you recognize, you identify minus 3.4 as the second energy level or the first excited level as they say, okay. So if you identify that, you can easily find, or else you will have to do the E by n square method, 13.6 by n square, and find the n value and all. So just try to know which is which level, you can easily do it. Alright, next question. M and n represents mass of neutron and proton. If an element having atomic mass m and n neutrons and z protons, n neutrons, z protons, and the correct relation will be very simple. So the actual mass of the nucleus will be lesser than the supposed mass. Supposed mass is when you take the total mass of the, calculate total mass of the protons, total mass of the neutrons, in fact means indeed the total mass of the nucleons altogether, actual mass is lesser than that calculated one. Okay, so that is m is lesser than the calculated one. Actual mass is lesser than the calculated one. It goes to the mass defect and energy, binding energy, all that. So I hope you people are aware of that. It's a very simple question. Option A is the correct answer. Okay. Next, the binding energy per nucleon for deuterium, okay, 2H deuterium, and 4 is respectively 1.1, 7.1 mega electron volt. The energy released when two nuclei of deuterium form a helium. First of all, binding energy per nucleon and binding energy are two different things. Binding energy per nucleon is an indicator of the stability, whereas binding energy is actually a quantity, a kind of measurable quantity of the nucleus, how strongly it is bound together. Okay, that is binding energy. Now, binding energy is what is used to find the energy released in reactions. Okay, so first we have to find binding energy from binding energy per nucleon. How do you find binding energy? Binding energy is given as binding energy per nucleon. Okay, first let's find of the deuterium. Binding energy into number of nucleons, that is 2. So this is 2.2 mega electron volt. Similarly, we can find binding energy of helium. So binding energy per nucleon into total number of nucleons, this is 28.4 mega electron volt. So this is the binding energy. Okay, now we are clear with the binding energy. How much energy is released in the reaction? What is the reaction? Two nuclei of deuterium gives you one single nuclei of helium. So it's a fusion reaction basically. So how do you find Q factor? Binding energy of the reactant minus product. What is the reactant binding energy? 28.4 mega electron volt minus binding energy of the reactants. Products minus reactants. So product is 2 times. The hydrogen binding energy is 2.2. So we have 28.4 minus 4.4, exactly 24 mega electron volt. Very simple question, right? So first of all, you have to understand that binding energy and binding energy per nucleon are two exclusive quantities. One is stability, one is just telling you the just a measurable quantity binding energy of a nucleus. From that, after finding the binding energy, you have to perfectly employ it in the formula of Q factor. Okay, Q value is the energy released in a nuclear reaction. So this is the reaction, and how do you find binding energy of product minus binding energy of reactant, and ultimately you get the answer. All right. So this is a very important question. These kind of questions can repeat. Please make a note, students. Mark this question as an important question. All right, next one. Nuclear force exists between. We have seen the same question before in the previous mock test analysis. Nuclear force exists between all the nucleons, proton, proton, neutron, neutron, proton and neutron. So combinations are possible, all of this. So the correct answer is option D. All right. Now let us look at the next question, shall we? The next question is given as, yes, when germanium is doped with 1 part in a million with indium, its conductivity increases by a factor of. So indium is kind of a trivalent impurity. We are putting it in 1 million part. So the conductivity is 1 million. Okay. So conductivity is actually almost inversely proportional to now the amount of distribution. So you give it to lesser number of quantity, more number will be. So it's inversely proportional, right? So when you have the same number, 10 to the power 6, the concentration will also be similar, that is 10 to the power 6. So you are distributing indium in 10 to the power 6 per million, okay, per million. That is 10 to the power 6 comes in the denominator. Okay, so that is the distribution. Now conductivity is inversely proportional to distribution. So that 1 by 10 to the power 6 will come to the numerator, that is 10 to the power 6. So conductivity and distribution has an inverse relation. More the distribution, okay, less will be the. So if you are distributing among a larger group, conductivity obviously will be less, because now what you are giving for 1 million, if you give you same for 1 billion, the conductivity will be less, the effect will be less, concentration will be less. Same amount if you give it for 1000 people, conductivity will be more. Okay, so same portion is divided across a larger portion and a smaller portion. So conductivity has an inverse relation like that. So when you do it per million, the conductivity will be so much. All right. Once again, easy question. This is a logical question. Look at the next one. A pure silicon at 500 Kelvin has equal number of electron and holes. It's an intrinsic semiconductor, has 1.5 10 to the power 16 per meter cube per unit volume. Doping by indium. First of all, notice this. Indium is a trivalent impurity. It will give you a P-type semiconductor. It won't give you an N-type semiconductor. So N-type is wrong. Actually, indium is a trivalent. It won't give you N-type. It will give you a P-type. So from these two, you have to find now what is the dope semiconductor is of. Now the only thing you have to finalize here is what is the number of electron. What is the number of electron? So for that there is a relation. I don't know how many of you remember this. Most of you take semiconductors chapters formulae for granted because you think that's a concept heavy chapter. So concepts will be asked but not the formula. But there is a very important formula which usually is stressed upon, that is how to compare an extrinsic semiconductor and intrinsic semiconductor. The number concentration in intrinsic semiconductor square is equal to product of number concentration of electron and holes in the extrinsic semiconductor, provided it's a thermal equilibrium. There is a thermal equilibrium. So same temperature. Okay. All right. Yes. So now just substitute all the given values. We have intrinsic semiconductor concentration as 16. So you have to square it. Ne is equal to NH is 4.5 10 to the power 22. Okay, so calculating both of this, you will ultimately get 1.5 square is 2.25 divided by 4.5. Yes, it is approximately 5 into 10 to the power 9 per meter cube. So the correct answer is not this, it is this. All right. So 1 second. Yes, it is not 2.5, it is 5. All right. So this is how you do this question. Okay. So this formula is the key with which you can ultimately pinpoint at the correct answer. Otherwise, by looking at indium itself, you can say it's a P-type semiconductor. Okay, that is okay. So you can delete two of the wrong options and ultimately end at B and D. But now you have to ascertain the number of electrons. How do you do that? This is the formula. Okay. So the square of the concentration of intrinsic semiconductor is equal to the product of electron and charge carriers, majority minority in the extrinsic. Okay, this is a very important relation. Next, so PN junction shown in the figure act as a rectifier, alternating current is shown. The current in the resistor can be shown by what is the output current. So the load takes some resistance, load resistance takes some output current, draws an output current. What is this? So first of all, we have only one diode. When we have only one diode in a circuit of rectifier circuit, it's a half wave rectifier. So we only induce half of the waves. So the correct answer is option B. Very simple. So one diode, half wave rectifier, half waves. Okay, very simple question. Next, a charge particle with a Q enters a region of constant, uniform and mutually orthogonal fields E and B, velocity V perpendicular to E and V, comes out of without any change in the magnitude or direction, then D is. First of all, I have told you it is E cross B. Okay, E cross B gives you the direction of velocity or the propagation. It's not B cross E. Okay, so actually option A and C are wrong. It's not B cross E. Cross product is not commutative, so order is very important. It's not B cross E. It is always E cross B. Now there are two E cross B. What is the final answer? So ultimately the charge comes out without any deflection. Okay, without any deflection. So in that case, we are talking about velocity selector. Charge comes out without any deflection. Velocity selector. We all know that for a velocity selector, velocity is given by E by B. Now, when is that possible? Is it in case of B or D? Let's check. Take B. So V is equal to E cross B divided by B square. Let's check. So when you take the magnitude on both the sides, it is EB sine theta divided by B square. Now they are perpendicular, E and B are orthogonally perpendicular. 1B cancels, so the final answer comes out to be B. Yes. So the correct answer is obviously it is option B. It is not option D because we don't want E by E or B by E. We want E by B. Okay, so the correct velocity selector formula is E by B. So that is obtained from this particular option, option B. When you extrapolate, you will get this answer. All right. Yes. So actually easy question because all of this is supposed to be known. But if you are not very keen with the electromagnetic waves chapter, then this could be a difficult question for you. Okay, so electromagnetic waves is very small. There are only very few topics. So I really suggest you please cover that as soon as possible because that will remain with you. Okay, very few concepts. If you just go through it twice or thrice, it will remain with you. Okay, you need revise it again. Fine, let us look at the next question. If momentum P, A and time T are taken to be fundamental quantities, then the energy has a dimensional formula of. Now we are talking about dimensional formula. First of all, let's talk about the formula. So we are talking about energy. It is proportional to momentum. Okay, let's have a power A. How we don't know how it is proportional. Is it directly proportional to square, inversely proportional to square, root? We don't know. Area B and time C. Now let's take the dimensions on both this side. Let's take the dimension. So we have ml square t minus 2 for the energy. Okay, no doubt. Then momentum is ml t minus 1 in power A. Then area is L square power B, then T power C. All right. So now just tag everything on the RHS. Just group all the individual terms separately. So M you have to the power A, and L you have power A plus 2B, and T you have minus A plus C. Okay, and on the LHS you have ml square t minus 2. Now using the principle of homogeneity, just match on both the sides. So you can know that A is equal to 1. All right, A is already equal to 1, and look at the power of B. So you have A plus 2B is equal to 2. A is equal to 1, just substitute, which implies that 1 will come this side. B is equal to 1 by 2, A is equal to 1, B is equal to 1 by 2, and ultimately C, you can equate the third term, the power of T, minus A plus C is equal to minus 2. So minus 1, put minus 1 over here, C will be, okay, C is equal to minus 1. All right, yes. So this is the correct representation. Ultimately, which of them matches? Power of momentum is 1, power of area is 1 by 2, okay, and power of time period is minus 1. So the correct answer over here is, as you can see, it is option D. All right, so the correct answer over here is option D. So the same way, this is kind of a dimension analysis that we do perform in the classes as well, in the PU class. So you have to take the those particular quantities with their respective powers and then express ultimately in terms of fundamental quantities only, then tag them, identify the powers, and then you can write like this, like a dimensional formula. You can create your own dimensional formula. You can create several derived quantities as fundamental quantities and express in terms of other derived quantities, like for how energy we found out using momentum, time and area. All right, fine. So these kind of questions have to be practiced a lot. Please mark this, okay? Definitely to be practiced a lot, very important question. And this takes a lot of effort as well, because you have to be very careful. Even a single point can lead you to wrong answer, because all of them are almost looking same. They all look very similar. So it can lead you to wrong answer. Okay, look at the next. Velocity time graph for a moving object is shown in the figure. The total displacement of the object during the time interval when there is a non-zero acceleration and retardation. Okay, so when there is non-zero acceleration and retardation, what is the displacement? Now, where is the non-zero acceleration? Look at this. During this point, okay, as you know, in a velocity time graph, if the lines are, okay, the line representing the motion is parallel to x-axis in a velocity time graph. they are uniform motion. Okay, they represent uniform motion. There is no acceleration. Okay, it's a zero acceleration. So these red zones represent zero acceleration. That's not what we want. We want non-zero acceleration, displacement due to non-zero acceleration. That is represented by this particularly this blue side. Okay, this triangular, everything underneath the triangle. Okay, so displacement is the area under the curve. So this area will give you the area of displacement of non-zero acceleration. So how do you do that? So find the area. Area is very simple. So you have one triangle and a rectangle. So the displacement is given as, now you can see this rectangle, it is this particular portion. Okay, so we have base as 20, height is 1. So 20 into 1, that is rectangle is done. Now triangle, half base into height. So half. Now the base is 20 once again, and the height is 4 minus 1, 3. Okay, so this is 10, this is 30 plus 20, 50 meters is the correct answer, option B. Alright, once again a very simple question. Okay, so please keep it in mind. You have to identify in a given graph which is uniform motion, which is constant acceleration, non-zero acceleration, zero acceleration, and ultimately find the displacement. Displacement is very simple from velocity time graph. Any like you choose a particular range and then area under the curve is essentially the displacement. Alright, very simple question. Next question, a person aiming to reach the exactly opposite point on the bank of the stream is swimming with a speed of 0.5 meter per second at an angle of 120 degrees with the direction of the flow of the water. The speed of the water in the stream is, now you have to analyze, this is a vector quantity because there is angle involved and you have two particular components. Namely, the first component is the velocity of the river. Okay, it's in this particular direction. Assume it in this particular direction, flowing in this. Man is swimming at an angle 120. The total angle is 120. That means you draw a perpendicular, and this is once again the velocity of the river, velocity of man component, and this you can split into 90 and, okay, hold on. The total angle is 120 degree and the individual angles are 90 and 30. Okay, so it's just now you have broken down the question to a very simplistic format. So this is the direction of the man swimming. The currents are flowing in this direction. So there is an angle 30 between them. So if you see this figure which represents a triangle, so you can apply that the sine of 30 is actually opposite by hypotenuse. Opposite is the river velocity divided by the hypotenuse is the man's velocity. So 1 by 2 is equal to VR divided by man's velocity 0.5. Cross multiply, you will get VR is equal to 0.25. The correct answer is option C. Okay, correct answer is option C. So you just have to break down the question into its most simplistic parts, that is represented using vectors. Okay, so you will have some kind of an idea how to apply it using the given angle. Okay, so we have 30 degree opposite by hypotenuse, easily you'll get the answer as 0.25, right? Very simple question. Okay, just have to break it down, otherwise it will be difficult. You have to be very strong with your mathematical perspective, that vectors and trigonometry, then it will be easy, otherwise it will be difficult. So please practice on your basic mathematics required for physics, very important. Okay, next look at this. A conveyor belt is moving at a constant speed of 2 meters per second. A box is gently dropped on it. The coefficient of friction between them is 0.5. The distance that the box will move relative to the belt before coming to a rest on it is. Now first of all, let's consider the equilibrium portion. So considering the equilibrium portion, we can equate two forces here. The force experienced by the box equal to the frictional force. Okay, so because of frictional force, there is some force there which makes it move. Okay, inertial force equal to the frictional force. So you can cancel out similar terms, and acceleration you can narrow it down to mu into g, which is 0.5 into 10. So you will get acceleration is equal to 5 meter per second square. Okay. Now once you have the acceleration, you have the initial velocity. So initially the conveyor belt is moving at 2 meter per second. So you can take initial velocity as 2. Okay. Ultimately the box comes to 0. It comes to halt. Final velocity is 0. Now you have to find the displacement. So how will you find displacement? So you will have a v square minus u square is equal to 2as. v0 minus 2 square is equal to 2 into 5 into s. So you have minus 4 is equal to 10s, which implies s is equal to minus 4 by 5 minus 3 by 8, sorry, minus 2 by 5, which is essentially 0.4 meters. The correct answer is minus 2 by 5, that is nothing but 0.4 meters. Okay, with respect to the conveyor belt, it is negative. So conveyor belt is moving forward. With respect to that, it is moving backwards, slightly jerking backwards. So that is 0.4 meters. All right. So this is the correct method of solving it. Once again, it's actually simple, but you need to have the proper conceptual flow right from getting the acceleration, assuming all the given values and applying the equations. All right. So that's where it is slightly tricky. Otherwise, it's a simple question. Okay. Next question, the penultimate question. A body of mass 5 kg is moving with a momentum 10. A force of 0.2 newtons acts on it in the direction of the motion for 10 seconds. The increase in the kinetic energy is, once again, it's not very simple question. You have to kind of translate this question in words into proper mathematical expressions. So look at this. First of all, its initial momentum. They have given that initially it moves with a momentum 10 meter per second. Okay, that is given. Now there is a force acting on it, 0.2 newtons in the direction of the motion for 10 seconds. Okay, in the direction of the. So we know that actually according to second law, F is equal to delta P by T. Delta T. Delta T is a 10. So force is equal to 0.2 and delta P by delta T, which is 10. So delta P is equal to 2 kg meter per second. Okay. So this is the variation in the momentum. So now you can find that the final momentum, if initial momentum is 10, there is a positive variation of 2, the final momentum is 12, sorry. So you have the initial momentum, you have the final momentum. Now it's very simple. Kinetic energy is actually P square by 2m. Okay, so all of we know that P square by 2m, correct? So all of us know that, and we have change in kinetic energy is K2 minus K1. So 2m is constant, 2 into 2m, P2 square minus P1 square. So we have 1 by 2 into 5, 12 square minus 10 square. So all of you can calculate this, 12 square is 144, 10 square is 100, 44 divided by 2 into 5, 10, 4.4, simple. The correct answer is change in kinetic energy is 4.4. So the correct answer is 4.4. All right. So yes, not very easy. You need to know all this, like from the initial momentum, how do you get the final momentum? Okay, how do you get the final momentum? You have to use this very carefully, and then you have to apply the kinetic energy formula, kinetic energy momentum formula. So this is a very important formula. You can apply this and ultimately get the change in kinetic energy. All right. So yes, you have to again trade through each step carefully, then you will end at the correct formula properly. Okay. Yes. Now the last question, let's discuss. So the thin uniform rod of length L and mass m is swinging freely about a horizontal axis passing through its end. Its maximum angular speed is omega. Its center of mass rises to a maximum height of. Now picture this event, what is happening. So you have a ceiling to which you have attached a rod. Okay, a rod is simply attached. Now it is swinging, assume it is swinging. Okay, so it has gone to its maximum displacement amplitude. All right, so this is actually its center of mass. Center of mass has gone to this particular point. So what is the height to which the center of mass has reached? Okay, this is the center of mass. So what is the height it has reached? That is the question. Now basically we have to use the conservation of energy here. Conservation of energy means mgh, okay, the gravitational potential energy gained is equal to the half I omega square, rotational kinetic energy. Okay, so for a rod axis passing perpendicular to the length through its end, not center, okay, through the ends. Center means it will be ml square by 12, but it is through the end, so we have to replace I with ml square by 3. Through the ends, the I value is ml square by 3 into omega square. So mm cancels and 2 into 3 is 6. So ultimately we have h is equal to L square omega square into 6g. Okay, so the correct answer is option D, 1 by 6 L square omega square by 6g. All right, yes. So this is the correct answer. This is how you do it. Okay, so you have to once again, the conceptual flow is very, very important. So identify the situation, translate into a proper diagram. Okay, then see what you have to find. Though this height, then you have to equate energies, and you will get, and also you need to know certain standard moment of inertia values also for a rod through the center, through the edge. Okay, cylinder through the center, through the edge. All of this is supposed to be known, and ultimately you will get the answer like this. All right, not a simple question. It is somewhere between medium and difficult. So system of particles and rotation is actually, kind of dreaded by most of the students. So I would really like you to focus on this chapter more and more so that you gain your confidence. All right, so we have come to an end of our discussion, and at the end I would really like to request all of you to once again join our WhatsApp channel. That is for all the updates regarding the KCET Abhyas mock test series, or whether it's our crash course. So regarding all of that, the information is readily available in the WhatsApp channel. So the joining link to the WhatsApp channel is given in the description box. So all of you, I urge all of you, definitely please join the channel for much and more updates. And finally, I hope you have really liked our video. So please press the like button if you have. And let me remind you once again, students, there are a lot of people out there who are in dire need of such content, such genuine content. So please share the video to as many people as possible. And at the end, but last but not the least, don't forget to subscribe to our channel Diksha Karnataka. So we are again coming up with a lot of mock test series preparation videos, and how to crack examinations very quickly, and analysis solutions for previous year questions as well. All of that is streamlined, and it is coming to you. So please don't forget to subscribe, and for timely notifications, don't forget to press the bell icon as well. All right, so that's it from my end, students. Until the next time we meet, adios.